Okay, 1.3.4, writing linear inequalities. To get started, what I'd like you to do is read through these and determine which inequality you think matches each word. So like, for example, if I wanted to say, I have under $5. Would that mean I have greater than $5, less than $5, greater than or equal to $5, less than or equal to $5, and so on? So pause the video, fill those in. Okay, we're back. All right, if I have under $5, that would be less than, because it cannot be equal to. Over would be greater than. I have at least $5, means I can have $5 or I can have more, so that's greater than or equal to. I have a maximum of $5, so that means I can have less than $5 or less than or equal to. I have a minimum of $5, meaning I can have more than $5 or equal to $5. I cannot have $5, so I can have greater than, I can have less than, I can have equal to. I have no more than $5. No more than. So I can have less than $5 or equal to $5. And I have no less than $5, meaning I can have $5 exactly or I can have more. Okay. All right, so the focus for today is writing inequalities, and then we'll be doing some graphing. So to get started, it says, you're hitting the road again, this time on a tour of colleges. This time you've traveled 200 miles already. However, you want to travel at least 50 miles per hour for the rest of the day, so you can reach your next school by the end of the night. Write an inequality that explains this scenario. So you may notice some of these key words. So remember when we talked about writing out writing out scenarios for linear functions, so like y equals mx plus b. We use words like already or started with for that b value, and we use words like per or every for our m, for our slope. So this is telling us that our b value here is 200, and our m, or our slope, is 50, because we're going 50 miles per hour. Next, we need to determine what type of inequality we have, and that's where at least comes in. So at least 50 miles per hour means I can travel at 50 miles per hour or greater than. So we call that greater than or equal to, and that's coming from that at least. So when we're writing this linear inequality, we use that slope-intercept form, that y equals mx plus b, except instead of using equals, we use greater than or equal to, because we are talking about an inequality. We can have 50 miles or more. So y is greater than or equal to m, 50x, plus b, 200. Okay. All right, let's look at number 2. You didn't know this beforehand, but your best friend is planning on meeting you at the school. He has already traveled 150 miles today. So I see that word already again, but has a ton of speeding tickets, so he wants to drive under 40 miles per hour for the rest of the day. Write an inequality that explains this scenario. So again, we have already 150 miles. So already, your starting point, that tells you your y-intercept. Anything like per or every tells you your slope, because that's what's changing. You're doing 40 miles per hour. Next, we need that inequality sign. So in this case, it says, and that's the inequality is always connected to that slope. So it says he wants to drive under 40 miles per hour. So let's think about that. If he wants to drive under 40 miles per hour, can he drive more than 40 miles per hour? No, so it can't be greater than. Can he drive less than 40 miles per hour? Yes, under 40 would be less than. Can he drive equal to 40 miles per hour? No, so it's just less than, not less than or equal to. So our inequality would be y is less than mx 40x plus b. Okay. So this is how we take some information and then write a linear inequality. The next step here is being able to graph. So we're going to write the inequality and we're going to graph. So number 3 here. You're practicing for the upcoming basketball season. You have already taken 30 shots and want to take no less than 7 shots per minute. Write and graph a scenario that represents this situation. Be sure to label your graph. Okay, so you have already taken 30 shots. So that should tell you that's your B value. And want to take no less than 7 shots per minute. So we should have a B value of 30, an M or a slope of 7. Now that inequality sign is always tied to the slope. So no less than 7. So if I want no less than 7, can I have less than 7? No. Can I have more than 7? No less than 7, so 8 is no less, 10 is no less. You can have greater than. Can I have equal to 7? No less than 7, so it just can't be less than, so it can be greater than, it can be equal to. So we have greater than or equal to. And then our slope is 7, so we have 7x. Our y-intercept is b plus b. So there's the first part. We've got the equation. Now let's graph. So here, remember, time always goes on the x-axis. Whatever else goes on the y. So 7 shots per minute. So minutes will be on the x-axis. Shots will be on the y. I notice we have a y-intercept at 30. So that'll be our starting point. So let's just go by tens here. So start at 30. And then we can go by ones for our minutes. So our slope is 7. So that means we'll go up a distance of 7, so up to 37 and over 1. Up another 7, so 37 plus 7 is 44 and over 1. And you can keep going up and over. Now we're not just graphing a line, we're graphing a linear inequality. So we have to determine line type and shade type. So since it has that equal to part, we have a solid line. Remember, if it's not equal to, it's dashed. Since it's greater than, we shade above. So when you're graphing these, make sure you consider that inequality sign, because you'll need a line type and shade type. Okay. All right, we'll do one more, and then I'll have you try a couple on your own. You and your friends are going trick-or-treating. You already have 35 pieces of candy and want to get at least 7 per minute. Write and graph a scenario that represents the situation. So it says we already have 35. So 35 will be our B value. We want to get at least 7 pieces per minute. So 7 will be our M. And it says at least. So we think about what at least means. So at least 7 means we can have 7 or we can have more than 7. So we call that greater than or equal to 7x plus 35. So let's plot this. So it's 7 pieces per minute. So time on the x-axis, pieces then on the y. We can go by ones for our minutes. For our y-intercept here is 35, so let's just go by tens again. So 35 is our starting point, that y-intercept. Our slope is 7, so that means we go up 7, so up to 42 over 1. Up 7, up to 49, over 1. Up 7 to 56, over 1. So we've got 4 points. Let's consider our inequality. So remember, greater than or equal to. So because of that equal to part, again, it's a solid line. Because it's greater than and not less than, we shade above. All right, here we go. 2 problems here. I'm gonna ask you to read through them, try them on your own, and then I'll talk through how we get both of those problems. Pause the video, give it a go. Okay, so it says you want to download songs to your iPod. You already have 40 songs, so B is 40. You can download a maximum of 5 per minute. So per being that slope, maximum of 5 per minute. So maximum is the highest. So if you think about a maximum, 5 is included. We can have 5, or we can have anything less. So that's less than or equal to 5x plus 40. Write and graph a scenario. So it's songs per minute. So minute, songs. I'm gonna go by tens again, just because I know that'll fit. Go by ones on the x. So y-intercept is at 40. We have a slope of 5 over 1, so we go up 5 over 1, up 5 over 1, up 5 over 1, up 5 over 1. And we have that or equal to sign again. So we should have a solid line. This time it is less than, so we shade below. Okay. The other one. You have sold 20 tickets to the dance. Every lunch period, you want to sell no less than 3 tickets. Write and graph a scenario that represents this situation. So we've sold 20, so that's our starting point, our B value. We want to sell no less than 3 tickets every lunch period. So our M is 3. It says no less than. So it can't be less than, so that means it can be greater than, or it can be equal to. So 3 tickets per period, starting at 20. So as we consider this, our time is lunch periods. That's our x-axis. Our y-axis here would be tickets. We're starting at 20, going up by 3s. I'm going to go by 5s this time. You could go by 10s again, that'll work. So we start at 20. Let's go by 1s here. We go up 3 over 1. So up 3 to 23 over 1, up 3 to 26 over 1, up 3 to 29 over 1, up 3 to 32 over 1. We are greater than or equal to, so that or equal to part means solid line, greater than means shade above. Okay. Last two. Again, why don't you read through these, write your own function, graph it yourself, and then we'll talk through them. So pause the video, give it a go. Okay, we're back. So you have $50 in your pocket, and at work you make a minimum of 20 per hour. Minimum means at the very least, so you can make 20 or you can make more. So there's our inequality. So it's money per hour. So hours is on the x, money is on the y. We're starting at 50 and we're going up by 20s. So, going by 10s probably won't work. Let's go by 25. So we start at 50. We go up 20 to 70 over 1, up 20 to 80 to 90 over 1, up 20 to 110, 20 to 130. And it is greater than or equal to, so solid line, shade above. Number 2, you've been bad, so the teacher made you write I will be good 1,000 times. You've already written 45 times, so that's your B value. Your goal is to write at least, so greater than or equal to, 10 times per minute. So 10x plus 45. So minutes is your x, times written is your y. We can go by 1s here. 45 is our y-intercept. We go up by 10s. Let's go by 20s here. You can pick whatever you want as long as it fits. So 45, up 10 to 55 over 1, up 10 to 65 over 1, 75 over 1, 85 over 1. It's greater than or equal to, so solid line, shade above. And there we have it.